Hi, Kinesiology 4120. Welcome to our program design part 3 on endurance and conditioning. Um, so we're going to really talk about today factors that contribute to fatigue and really energy system development. So fatigue is really what's going to limit the utilization of each of our energy systems. We have to know where that fatigue comes from so that we can create training programs to develop those energy systems. Okay, so let's talk about fatigue. Fatigue, first of all, is the slowing of a metabolic process in most cases when it comes to talking about endurance or energy system utilization. So that feeling of tired or that slowing of our work output. And we have neurological contributors to fatigue. So this could be the availability of carbohydrates because our nervous system runs strictly through carbohydrate metabolism. It could be the availability of sodium. Um, we know sodium is utilized in those nervous system connections within the muscle in order to stimulate muscle contraction, and pH. So the level of acidity within that tissue can affect that nervous system drive. Okay, so that's our first level of fatigue. The next level is the muscular system. So we can look at energy substrate availability within the muscle. So um, glycogen availability, um, fatty acid availability, where those substrates are, how much we have within the muscle. We look at metabolic speed, so how fast we can utilize each of those metabolic pathways uh, because they are limited in their speed of energy production. And then we have other factors like pH and temperature that can affect the muscle itself by slowing metabolic speed or forcing the utilization of other metabolic pathways. Okay, the next one is our circulatory system. We're looking at strictly at the blood. Okay, what's our blood glucose availability? If we have more blood glucose, we can use that substrate for metabolism. We have fatty acid availability within the blood. There's also oxygen and carbon dioxide concentrations within the blood. So how much we have of each can influence our fatigue from mostly those aerobic pathways. We have lactic acid, so that acidity is going to slow down reaction. Hydrogen ion buffering abilities, um, capillary density, so really how much blood we can get into the muscle, and then how much of those chemicals like oxygen, carbon dioxide, as well as our energy substrates can get into the muscle, and those that acidity, those hydrogen ions, and the CO2, how much we can get out of the muscle from our circulatory system. Our liver can also be a location of fatigue, so that's how we get glucose into the bloodstream is through the liver. So we break down glycogen into glucose and send it out into the bloodstream. If we don't have enough glycogen available, we can't produce as much glucose to send it into the blood. And from the heart, we have stroke volume, heart rate, our vascular system. So if we think about heart contributions to fatigue, this is often going to be during aerobic training. Our stroke volume is going to be a limiter. Our heart rate could be a limiting factor if we're older, we're masters athletes, unfit athletes, being able to push into those heart rates and having the blood volume to handle high stroke volumes can be an area where we have to train to develop more of a fatigue resistance. And then lastly, looking at the lungs are often not going to be a limiting factor or cause for fatigue, but if we look at the inspiratory muscles, that's going to be an issue. So that comes back to muscular fatigue, but for those inspiratory muscles like our diaphragm, our intercostals, our scalenes, everything that's going to change the pressure within our thoracic cavity. And then if we have some kind of condition within the lungs, something like asthma, we're maybe not able to get as much air in or out, that's going to limit the amount of the amount we can transfer in and out of each alveolus because we have to get that air in and we have to get that carbon dioxide out. So let's look at how we can program to really develop fatigue resistance through these pathways and within our energy systems. So if we look at what endurance is our ability to stave off fatigue or resist fatigue. Okay, we can do that at the muscular level, okay, through muscular endurance. We've talked about muscular endurance probably in your introductory classes. The ability to perform submaximal muscle contractions for extended periods of time. We have long duration endurance, so things like marathon running, endurance cycling, endurance swimming, where we're continuing to move for long periods of time submaximally. And then we have interval-based endurance, which is our ability to work and rest, work, rest, work, rest, work, rest, which is where we see most of our field and court sports are within this interval endurance spectrum, which can be either aerobic interval endurance, so longer durations where we're working hard aerobically, recover, aerobic power, recover, or we can look at it anaerobically where we're doing anaerobic outputs, recover, anaerobic outputs, which is really going to be the major piece for most of our sports is anaerobic interval endurance. And each of these factors can contribute to each other, but anaerobic interval endurance is probably going to be the one that transfers the most to most field and court sports. If you're looking at other sports that are more aerobic in nature, if we look at something like swim, competitive swimming, where we're performing multiple events, especially if they're aerobic events, or track, where you have aerobic events and then you have recovery periods and then you have to re-engage in that event, that could be an issue with aerobic interval endurance. Or sports where you are continuously moving at high outputs, we're going to need that aerobic interval endurance. Very few field court sports are going to use long duration endurance. Some may require muscular endurance within specific efforts and for certain time domains. So you may need something around 10 seconds of muscular endurance for something like football, American football, where a lineman is blocking. They're going to need to endure those contractions at near maximal efforts for repeated bouts, which could turn more into an anaerobic interval type of work. So how can we modify our variables to look at all of these components of muscular endurance, interval-based endurance, and long duration endurance? For muscular endurance, we have to look at each of these pieces. The first one, exercise choice. It has to be localized to the muscles. So you cannot perform bicep curls and expect muscular endurance to be developed in your quadriceps. It has to be specific to the muscle. We can manipulate the speed of contraction based on our needs. So this could be very slow endurance or near isometric or zero endurance, zero speed, where we're holding, maintaining positions. This can be rapid contractions where we're producing those contractions over and over and over and over and over. We can look at it as muscle action specific. If we're training, we'll often use isometric methods to develop muscular endurance, especially of those muscles that require it, which are often postural muscles. So we'll often use something like an isometric contraction to develop stabilizer muscular endurance, because we'll often use those stabilizers of the trunk or of the hip or the shoulder, or of the forearm for grip. We're trying to develop isometric muscular endurance in most cases to hold that joint together and keep it stable while we're producing force through those more large, powerful joints. We want to really avoid eccentric or minimize eccentric work during muscular endurance activities because it can cause major physiological damage to the muscle. So we know that eccentric muscle actions are more damaging. If we're doing repeated eccentric efforts, it's going to cause a lot of damage, a lot of soreness, and we want to minimize that often when we're trying to train for muscular endurance because the recovery curve is going to be very large. If you do a lot of eccentric work, you're going to need more time to recover between training sessions. And we also want to minimize using weightlifting movements and plyometric movements for muscular endurance because those are very ballistic, high power outputs, and we're not going to really want to work on high power outputs at a submaximal repeated effort standpoint. Those are kind of counterintuitive to do an exercise that is more conducive to explosive power development. It's often going to lead to less power development if we're doing that repeatedly submaximally. If you're trying to repeat or develop maximal power, you don't want to do it submaximally and repeated effort. So we can talk more about that and really get into the nitty gritty in that. For exercise order for muscular endurance training, we want to do this often at the end of training, or it's the only training session. Muscular endurance is very physiologically fatiguing, muscular endurance style training. So we want to limit doing that before we do any kind of speed, strength, or power development training, because it's going to limit the amount of work that we can actually do within that speed, power, strength type of activity. But doing something that is more strength development will not limit our muscular endurance development. So in the order of adaptations, it can be pushed towards the end and we can still have a positive adaptation. For frequency, we can do this very often unless we do a lot of eccentric loading with muscular endurance style training. So we know that the recovery curve is very, very long with eccentric loading. If we minimize eccentric loading, so we stick our muscular endurance as mostly concentric and isometric, we can do this very often. But if we use it with an eccentric style, we're going to have to give some time between sessions to actually recover those musculature. For intensity, this needs to be somewhere between 10 to 80-ish% of 1 RM. So we have a really large spread of intensity for muscular endurance style training. And then the volume is going to be really dictated by the intensity. So if we use something closer to 80-ish%, it's going to lessen our number of repetitions. If we do something that's more on the lower end of the spectrum, it's probably going to limit the sets that we perform. And we'll often use something around reps to failure for muscular endurance training. So we'll either use a specific time domain, so 30 seconds, 40 seconds is going to be a good window. And then we're going to push the intensity based on how much strength we require within the muscular endurance within that sport. If it requires high levels of strength with endurance, we're going to have to push the intensity higher. If it needs low level of strength, but higher levels of endurance, so something like maybe it's kayaking or skiing where you need less levels of maximal strength, but you need it for extended periods of time, we can really manipulate our intensity and our volume based on our need. And then the rest is often going to be shorter, somewhere between 30 seconds and 180 seconds or 3 minutes, depending on the intensity. High intensity, longer rest. Lower intensity, less rest. And then we can manipulate the rest to really push the endurance end of that spectrum. If we're trying to work on the strength endurance portion, we're going to need to include more rest in order to get the quality work required. With interval-based endurance, okay, this really is a combination. We can plug and play with muscular endurance style, aerobic style, anaerobic style, depending on what we need. Or we can do all of them together. They all really work because interval endurance is a work, rest style of training. That's what an interval is. It's on and off, on and off. So what are we going to manipulate here? For exercise choice, we're often going to be using complex movements, and we're going to work on fatigue and fatigue resistance for those outputs. If we're doing something muscular endurance, we may localize it a little bit more for intervals, but we'll often use very complex movement patterns. That includes things like sprinting, swimming, rowing, cycling. We can mix and match our movement patterns, really whatever you want to do. And we're trying to progress fatigue. Make sure that your choice, your exercise choice, fits with the sporting demands. If we're looking at the order of exercise, we'll often do this at the end of a training session or as its only training session. That's how it is with most of this endurance work, because endurance or conditioning is going to be more physiologically fatiguing and metabolically fatiguing rather than nervous system fatiguing. And we want to do that nervous system fatiguing work first, because if our nervous system's fatigued, we can still perform metabolic work If our metabolism is fatigued, it's going to limit our nervous system work already. So it's counterintuitive. Okay. And with frequency, we can do this extremely often as long as we minimize eccentric loading. So you can do a lot of interval anaerobic work with cycling because there's a very low eccentric load. With swimming, there's a very low eccentric load. Rowing, very low eccentric loading. However, things like running, jumping, things where you have a lot of eccentric loading, lots of complex movement patterns that have an eccentric phase, so things like squatting, lunging, it's going to be more difficult to do that at a high frequency. But if we use more cyclical activities, we can really push the frequency because the eccentric load is minimized, the recovery curve is minimized. With the intensity, we're really working higher than VO2 max. So we're not really looking at a load, we're looking at a metabolic work output. So that metabolic work output has to be higher than VO2 max for us to work in the anaerobic energy system. So we are working above VO2 max for all of our anaerobic work. Our volume is going to be somewhere like 3 to 12 sets, really depends on what we're doing. And we're working on this for time rather than for repetitions. For most anaerobic interval training, our total volume of work in the on phase or the go phase, not the recovery phase, the go phase, is going to be somewhere between 2 to 3 minutes of total work. So that means somewhere between 120 minutes and 180 minutes of total work within an anaerobic interval training session. It can be lower than that if we're looking at high intensity anaerobic work. So if we're looking at maximum sprint endurance, that work may be somewhere around 30 total seconds because we're really pushing the intensity. It's really our intensity and our volume are going to play off of each other just like they do in all of our other training outputs. So high intensity, you're going to have less total volume. Lower intensity, more total volume. And then our rest is based on a work to rest ratio. So this ratio is our work on compared to our work off, or our off time. The first number is work, the second number is rest. So the work to rest ratio. And with anaerobic interval endurance, we are completely recovering. We are not doing aerobic work. We're walking, standing, sitting. We're not trying to develop an endurance training within the rest portion. We are trying to recover fully so that we can have the highest output in our next anaerobic interval. So I'll give you some examples of this work to rest ratio. So a 3-to-1 work to rest ratio is a 3 compared to 1 work to rest. So that would be, say, 3 minutes on, 1 minute off. However, the issue there is it's an anaerobic work, so we can't have 3 minutes of anaerobic work. That's not going to work. It's not going to happen. So our on periods can't be longer than around 60 to 90 seconds individually. So this would likely be a 30-second, 10 seconds, or a 50 seconds, 10 seconds, or a 10 seconds, 50 seconds rest. So really depending on the intensity, lower intensity work is going to have a larger work compared to rest. The lower the work is, the higher the intensity it's going to be. So this could be 5 seconds of really hard work, 25 seconds of recovery. So they're played off of each other. It's a ratio of one to the other. Okay, now if we look at interval aerobic endurance, really remember this difference is anaerobic, so our work is going to have to be shorter to stay within the anaerobic energy system, and it has to be above VO2 max. With aerobic interval, we're choosing complex muscle groups. We're working for longer durations for this type of work. It's same with all of our endurance. It's done at the end or it's only session. Especially with interval aerobic, it can be done either. But if you're really trying to develop this energy system, you want to do it as its own training session. Same with interval anaerobic endurance. When it's its own training session, you're going to get the most bang for your buck. It can also be done often as long as we minimize eccentric loading. And often with interval aerobic, we'll use cyclical activities. We'll use cycling, running, swimming, rowing, things like that. So we're trying to develop aerobic capacity, or the ability to work at high outputs near VO2 max for longer periods of time. So we can use heart rate as an easier one to measure, so we know our maximum heart rate. We can work at an intensity around 80-ish% of that maximum heart rate, or we can push it near VO2 max if we know our VO2 max. We know the VO2 max heart rate, which we can estimate based on some calculations, but we're wanting to push at a high heart rate, and our emphasis is on maximizing speed of movement for long duration. So maximizing output for extended periods of time. So the volume is going to be similarly 3 to 12 sets, and we're going to use a time period based on a work to rest ratio. The work to rest ratio, the work is going to be longer because we're working on aerobic capacity. So this could be a 6 minutes on, 2 minutes off work to rest ratio, which I've done that with running. It is extremely challenging to work at near max heart rate at towards lactate threshold for 6 minutes, get 2 minutes to recover, and then you have to go right back onto that output. It's very difficult. And we can do a lower durations. Often we'll use a 1-to-1 or a 1-to-2, where a 1-to-2 would be say 2 minutes of work, 4 minutes of recovery, or 1 minute of work, 1 minute of recovery, 3 minutes of work, 3 minutes of recovery, something like that. You choose your work to rest ratio based on the energy system demands of your sport and the work to rest ratios within your sport. Or you're using that work to rest ratio to maximize high output work or to maximize duration of work that you're trying to perform. If you're trying to do long durations of work with maximum recoveries, you're going to have longer rest periods. If you're trying to maximize the repeatability of work, you're going to have lower rest ratios, especially if that sport demands lower rest ratios. And then we can put them together. We can use anaerobic and aerobic intervals and push higher intensities in each one. Think about like HIIT training. That's really what we're doing here. We're managing a work to rest ratio, and we can mix and match anaerobic and aerobic work within the same session. But we have to know that the anaerobic, for it to be anaerobic, we have to be working above VO2 max, maximal outputs, and our aerobic outputs are going to limit our anaerobic outputs. So if we're going to do them in the same session, choose your anaerobics early in the session, aerobics later in the session, in order to maximize each, because the aerobic system can still work after we've depleted the anaerobic system. The anaerobic system does not work very well when the aerobic system is depleted. You don't recover as quickly unless your sport demands it. So if you're doing something like track swimming, where you have cycling, where you have to have a really high anaerobic work output at the very end of a session, then you can train that by using aerobic intervals and finishing the session with anaerobic intervals. So you can get creative based on your needs. And so there's no wrong answer as long as it fits the goal and you're managing recovery within that training. And lastly, long duration endurance. We can plug in all of these variables. First of all, we have to choose an exercise choice that can be done continuously. So often it will be something like running, swimming, cycling, rowing, something that can be done for long durations, continuously, and it's often going to be cyclical. So it's any continuous activity. Long durations, you'll use time, distance, less eccentric the better. That's how most of these are. And it's best to be done as its only training session. If you have to do it at the end of a training session, that's okay, but its own training session is going to be the best scenario for both your training session and the recovery from any other training sessions. It's best to do it as its own training session, about 6 hours away from your strength training session or your power training session. For frequency, it can be done extremely frequent, minimize eccentric loading, and minimize the intensity, manage the intensity to allow us to have higher frequencies. So if you're doing a long duration endurance training session and you have it at a very high intensity, it's going to cause a very large recovery curve. So it's going to take longer to recover. So manage that. If you're doing long duration endurance, but it's a shorter duration, lower intensity, you can do that much more frequently. This intensity must be lower than VO2 max. And it's very focused around high efficiency movement. So we're trying to get the most we can do at the lowest energy expenditure so we can increase the duration that we can handle. The more efficient we are, the longer we can work, especially at higher speeds. For volume, it's always going to be one set continuous, and it's going to be longer than 12 minutes. If it's not longer than 12 minutes, it's not going to really work into the long duration end of the spectrum. You're not going to have to utilize different energy substrates. You're not going to have to work for longer periods that way. You have to be longer than 12 minutes of work, continuous work, to fall into the long duration endurance category. I'll often put this as like a minimum of 20 minutes mostly. 20 minutes of continuous work, and then longer than that. This is often going to be focused around either preseason aerobic conditioning or aerobic energy system development at a low intensity. You'll use something like a long duration endurance format. So that's your 20-minute run, your 20-minute cycle, your 30-minute swim. But the focus is no rest. That's really what's going to work here, and it's going to be aerobic 100%. But it's going to help us work for longer durations rather than working specifically for the competition. This is building a foundation. So I recommend that everybody has at least some experience in programming and implementing long duration endurance, but you're wanting to do this if your sport is not focused around long duration endurance as a component of the sport. You're going to want to do this as far away from competition as possible. When you go into the periodization section, this will make sense. But we don't want we don't want rest within the session, and we want this to be continuous for long durations. This does not always improve VO2 max because VO2 max is dependent on the intensity of work. So you're not going to just improve your VO2 max because you work for a long duration. If I walked for 20 minutes, that is still long duration endurance, but it's at the lowest intensity, which means it may not improve my VO2 max unless I'm a very low fit individual. So if we push the intensity high for long duration endurance, it will absolutely develop VO2 max. However, it has to be near or upwards closer to VO2 max for us to really get those changes, because VO2 max changes are intensity dependent, just like speed, power, strength. Intensity is going to be the driver for maximal adaptations like VO2 max, strength, power, and speed. Those are maximal adaptations. We need maximal or near maximal training to actually stimulate adaptation within that system. Okay, so we've gone through all of our modifiable variables except for the last one, the P. So it's cofivert. The P is progression. Progression is modification. So how can we modify load, volume, movement complexity, rest? So how we can change our training to cause a continual improvement or a change in the level of adaptation that our athletes have developed. So once we've developed an adaptation and it's plateaued or it's stopped, or we're reaching that end of that adaptation, we have to make a change. And that change is going to be somewhere in the load, the volume, the movement complexity, the rest interval. These are all modifiable pieces. Okay, maybe it's a choice. Maybe it's how much we do, the frequency, the volume, that's what we fall into volume, the load, the intensity, whatever we're changing, it has to cause a progression within the adaptation we're shooting for. So how do we decide? First of all, beginners adapt to everything. So if we change something, it will make them better, which is awesome. But if we have athletes with a higher training age, so 1, 2, 5, 10 years of training, we're going to need more variation, more specific changes to really cause the development of the adaptation that we're going for. So how do we actually achieve this progression long term? Because we're looking at training an athlete for an entire year, multiple years. If you're an Olympic athlete, you're training for 4 years for a competition. So how do we achieve progression and continued development? If you're working with just a general client, you're trying to achieve progression long-term for their life. So how do we decide how to progress and how do we achieve progression? We use a method called periodization, or planned variation of modifiable variables to achieve a specific adaptation at a specific time. So we are periodizing we are planning when we are doing specific types of training throughout a year, multi-year cycle in order to achieve specific adaptations at specific times throughout the year. So one thing that we have to just get out of our head, you cannot be the best at every adaptation at any one time in particular. You cannot be the most aerobically fit, the most maximally strong, and the fastest athlete at maximum velocity at the same time. There's competing adaptations here. Okay, you can't be the best at long duration endurance and also the best at bodybuilding hypertrophy. Okay, the best at power lifters are not the best marathon runners. Okay, the best 100-meter sprinters are not the best mile runners. Okay, the best swimmers are not the best skiers. There's differences, and we have to know that we can't be the best at everything. We have to know what we have to get better at within the sport to cause our athletes to perform at the highest level, which is in most cases the goal of winning within their sport. So think about this. You can't have everything all at once. You cannot train for everything at one time. You will get very good at nothing if you train for everything. You'll get very good at something if you train for one thing. And you have to train for one goal, and we have to plan when we achieve these goals so that they build upon each other so that we can get the actual goal, which is perform well within competition. Okay, so we've discussed all of our different pieces. Periodization is our last one. We will go through the next lecture on periodization, go through that lecture also. And I hope this has kind of spurred your program design thoughts for your project. Start planning. Okay, start planning what are your program goals and start thinking through what we need to achieve for our athlete. All right, I have your additional review questions. Go through your review questions for part 1, part 2, and part 3 to help progress you towards your final exam. All right, thank you very much for watching.